Hi everybody. In this session, we'll discuss worksheet questions based on mechanical properties of fluids. Let us enter. A spherical drop of radius r is divided into 8 equal droplets. That means you need to do some work in dividing the droplet into smaller ones. If the surface tension is S, sometimes you will give T, sometimes S, not an issue. Then the work done in the process will be work done is equal to surface tension into change in area is the basic logic. Work done is equal to surface tension into change in area. What is initial area? A1 is just droplets, right? So only 4 pi r square is enough. 4 pi r square is enough. This is initial area. What about final area? Final area is 8 droplets came. 8 into 4 pi small r, very small r, so I can write it as small d as a suffix, small 4 pi small r square. Small r and the bigger droplet r relation we have to establish. How's our volume conservation? That is what 4/3 pi r cube is equal to 8 droplets into rd of cube. This is each droplet volume is equal to n droplets volume into 8. So r is equal to 2rd. That means rd is equal to small droplet is bigger droplet radius by 2. So 8 4 pi into r by 2 whole square. So this will be 8 into 4 pi into r square by 4. So this is just 2 into 4 pi r square. This is A2. Now work done is equal to surface tension into change in area. Change in area, final area minus initial area, that is equal to S into, this is 2 4s are 8 pi r square minus 4 pi r square. So you are going to have 4 pi r square into S. So this is the answer. 4 pi r square into S is the answer. Next. A soap bubble of initial radius r is blown up. The surface tension of the soap film is T. The surface energy needed to double the diameter of the bubble is, doubling the diameter nothing but doubling the radius. So initial radius is r, final radius is 2r. So work done is equal to surface tension into increased area or changed area or created area. Surface tension into final area is 8 pi, why not 4 pi? Because it's a bubble. So 8 pi 2r whole square minus 8 pi r square. Final area minus initial area. 8 pi can be taken common into, this is 4r square minus r square, 3r square, 3 8s are 24 pi r square into t. So this is the answer. Next, a metal cube of side A is equal to 10 centimeter rests on a film of a liquid of thickness T is equal to 0.2 mm. If upon applying a horizontal force of magnitude F is equal to 0.1 Newton, the cube slides with a constant velocity V is equal to 0.08 meter per second. Fine. Then the quotient of viscosity eta is equal to how much? We have the formula F is equal to minus eta A dV by dx. This can be changed to eta A V by T. So area is nothing but side is given. So A square we can take up. So we can take the formula as eta A square V by T is F. I am taking the magnitude. So negative sign ignored. Now that is equal to opposite force. That's why minus sign you can feel. And this is the color. So eta is equal to F by A square into V into T. Like this. So you need to watch the picture also. Eta equal to F 0.1 thickness 0.2 into 10 to the power of minus 3, because mm is given, converted into meters, and A square 10 into 10 into 10 to the power of minus 4 unit conversion into velocity. Velocity is 0.08. So this gives rise to, it's a simplified value, 2.5 into 10 to the power of minus 2, yes, Pascal second, which is option A. Yes, next. A hollow spherical body of outer and inner radii, let me draw the picture, hollow spherical body. 4 centimeter and 2 centimeter. 4 centimeter, 2 centimeter. Okay, one is 4, one is 2 centimeters it is. Floats half submerged in a liquid of density 2. The density of the material of the sphere is, floats half, it's floating half, like this, half submerged. For all these types of questions, you need to have one basic logical formula, that is upthrust is equal to weight of the body. Weight of the body is equal to upthrust. Upthrust is equal to volume of the body immersed into density of the fluid into gravity. This is upthrust formula. Weight formula is volume of the body into density of the body into gravity. This is equal to volume of the body immersed into density of liquid into gravity. Gravity first cancel. Now in order to calculate weight, volume of the body material you have to consider. Volume of the body material. Volume of the body material is volume 4/3 pi r cube minus r cube is the volume of the material into density of the body is equal to volume of the body inside is 4/3 pi capital R cube by 2 only, it's inside, only half is immersed, into density of the liquid. So density of the liquid L must be suffix, very small you need to write. Yeah. Now 4/3 pi gets cancelled. R cube, R value how much? 4 centimeter. So 4 cube minus 2 cube into 10 to the power of minus 6. Why? Because centimeters it is. Density of the body equal to R cube, 4 cube into 10 to the power of minus 6 by 2 only into density of liquid 2 gram per cc. I will put in gram per cc only, answer also will come in gram per cc. This also gets cancelled. So all are in centimeters, not a big task. 2 cube gets cancelled everywhere. Then it will become 2 cube minus 1 into density of the body, whatever I want, that is equal to, it will be 2 cube only because 2 cube is cancelled and this 2 gets cancelled. So rho b is equal to 8 by 8 minus 1 is 7. So 8 by 7 means 1.1, almost all are in 1.1 only, 1.1, then 3 will be left, 4 7s are 28, correct only, gram per cc. So whenever like this very close numbers are there, you should be very careful. When close numbers are there. Don't guess, need to do, because even after knowing the entire concept, some people have some laziness in simplifying the last steps. In the last they will guess. No, you want to guess in the first only. Or you want to do completely. Have such patience, otherwise don't attempt that question. If you feel that that's a lengthy calculated one, don't attempt. If you want to attempt, complete the question till the end. It will benefit. An air bubble of radius r is equal to 1 mm. An air bubble of radius r is equal to 1 mm is kept at a depth of 8 centimeters. Is kept at a depth of 8 centimeters. D is equal to 8 centimeters. Air bubble, okay, 8 centimeter, 10 power minus 2, mm 10 to the power of minus 3. So SI units. Below the free surface of a liquid column, if the surface tension and density of the liquid are, surface tension is equal to 0.1 and density D is equal to density, then rho I will write. or this h and that is d I will write. This is depth and this is d I will write. That is equal to 2000. All are SI units. Okay. All are SI units respectively. By what amount is the pressure inside the bubble greater than the atmospheric pressure? So HDZ plus 2T by R is the pressure inside. By what amount is greater than the atmospheric pressure? HDZ plus 2T by R is the formula. So H 8 into 10 to the power of minus 2. Density has given 2000, huh? Yeah, 2000 into G value 10 plus 2 into T value 0.1 by R value R 10 to the power of minus 3 is equal to excess pressure, whatever he is asking. So here 10 power minus 2, 2 zeros will go. So this is 2 8s are 16 upon with 2 zeros plus 10 power 3 will come. So it will be 200. That is equal to whatever the required pressure. That is 1800 Newton per meter square is the required pressure. We'll go to the next question. Matching. Stokes' law. Turbulence. Bernoulli's principle. Pascal's law. Pressure and energy. Hydraulic lift. Viscous drag. Reynolds number. Turbulence, Reynolds number, and Bernoulli principle, pressure and energy, Pascal's law, hydraulic lift, viscous drag, Stokes' law, isn't it? So A, Stokes' law, viscous drag 3, and turbulence, Reynolds number, Bernoulli's principle, pressure and energy. So it's A. Next one. In a horizontal tube of water pressure changes by pressure difference. Pressure difference is equal to 1500 Newton per meter square between A and B as shown in the figure. Okay. Cross sectional areas of A and B are as follows. One is 40 and the other one is 20 centimeter squares. I need to keep it in the mind. Find the rate of flow of water through the pipe. Rate of flow of water through the pipe. Volume rate is equal to AV. Actually area into velocity. So area into velocity. Here velocities are not given. So we need to go for another interpretation. That we will check. We have A1 V1 is equal to A2 V2. A1 is 40, V1 I don't know, A2 is 20, V2 I don't know. That means 2V1 is equal to V2. Representation 1 I can call. Next, what about Bernoulli's theorem? Bernoulli's theorem is P1 plus half rho V1 square is equal to P2 plus half rho V2 square. So pressure difference P1 minus P2 is equal to, here more velocity less pressure, here less velocity more pressure. So P1 minus P2 is equal to half rho into V2 square minus V1 square. So P1 minus P2 1500 into 2 by density given, not given. Density not given. Is it water? Then given only 10 power 3, that is equal to water only now. V2 square minus V1 square. V2 is equal to 2V1 square minus V1 square. 4V1 square minus V1 square is 3V1 square. I can write it as 3V1 square. So V1 is equal to 1500 into 2 by 10 power 3 into 3 under root. So 3 will go 500, 500 2s are 1000, 1000 will go. So everything gonna equal to 1 came 5. So now VT is equal to cross sectional area 40 into 10 to the power of minus centimeter square, right? So 10 power minus 4 into 1. So this is going to become 4 into 10 to the power of minus 3. This is volume rate, centimeter cube. Oh, centimeter cube only. This I did in meter cube. So yes, we did in meter cube. This is meter cube per second. So in centimeter cube, 10 power 6 must be multiplied. So it will become 4000. Yes, centimeter cube per second. So answer will be a U-tube is partially filled with an incompressible liquid of density 1.2 gram per centimeter cube. Let us draw an U-tube. U-tube. Okay. And this one also. Okay. Now this one is having liquid up to like this initially. Whenever you pour something, then it will be occupying on either sides equal. Now what he did, he poured this density D of what is that liquid is equal to 1.2 gram per cc. Oil which do not mix with the liquid is next poured into the left side of the tube until the liquid rises 15 centimeter on the right side of your tube. If you pour oil in this, it is rising. He said it is rising. It is rising means it should come down, isn't it? He said 15 centimeter raised. That means it will go 15 centimeter down. Up to here, this liquid is occupying the space. Okay. Next, its level finally this one. Its level finally this one. This is finally. Yeah. So if you think the common points, here is one point and here is also the same common point. If you feel this is initial one, this is final one. So that means it raised 15 centimeter and here depressed 15 centimeter. That means that also will be added here. So totally on the right side, 30 centimeters will be high of this particular liquid. And left side, this is suppose say H. Okay. So another one, D of oil. Density of oil is 0.9 gram per cc. Next, the liquid rises by 15 centimeter. Okay. So here, if the density of the oil is 0.9 gram per cc, fine. Then oil level will stand higher than the liquid in the U-tube by how much? Okay. That is D1 HDC, right? So H plus H of oil plus 15. So HDG is equal to 15 plus 15 into HDG, D2 into G. GG gets cancelled and H plus 15 into D1. D1 here I am writing this side is oil and this side as liquid. So oil is 0.9 and that is equal to 30 into 1.2. So this is 0.9. So H plus 15 is equal to 30 into 12 by 9. 3 3s are 3 4s are and 3 1s 3 10s. So it will be 40. So H is equal to 40 minus 15, that is equal to how much? 40 minus 15, 25 or 25. Yeah. So this is 25. 25 this one. Okay. And these two columns are differed by, from this point onwards, this is 25. From this point onwards it is 5. So the two columns are differed by x is equal to 25 minus 15, that is equal to 10 centimeters. So what will be the answer? B. Yes. Next, a typical question. A meniscus drop of liquid 1 centimeter is sprayed into 10 to the power of 6 droplets capital R is equal to 1 centimeter and the spread N is equal to 10 to the power of 6 droplets of equal size. Calculate the energy expanded if surface tension T is equal to 435 into 10 to the power of minus 3 Newton per meter. Energy required, that we have to calculate. For that, what is the formula? Yes, you are right. Work done is equal to 4 pi r square T into n to the power of 1 by 3 minus 1. 4, answer is not in pies. So 22 by 7 into r value 1 into 10 to the power of minus 2 square into surface tension 435 into 10 to the power of minus 3 into number of droplets 10 power 6 power 1 by 3 minus 1. So 4 into 22 by 7 into 10 to the power of minus 4 into 435 into 10 to the power of minus 3 into 10 to the power of 3. 3 will go 2 times, 2 in minus 1. Yeah. So 7 will go 7 once, 7, 42. Roughly 2 times. 7 2s are 14. Yes, yeah. So it is a nearest one. So after calculating 4 2s 88 and 88, 99, this can be 100 and that into 6.2, maybe roughly 54 point, yeah. 54.1 into 10 to the power of minus 3 Joule. Next, new question. Water tank kept on the ground. Water tank kept on the ground. Okay. Has an orifice, diameter D is equal to 2 mm. Okay. Unit conversion 10 power minus 3. And on the vertical side, what is the minimum height of the water only? So obviously density is known for us. Minimum height. Output flow of water is found to be turbulent. Output flow of water should be turbulent. Turbulent means Reynolds number must be greater than or equal to 3000. And we have velocity with that V is equal to R eta by rho D. R value 3000, eta value 1 millipoise 10 power minus 3 by rho is 10 to the power of 3 into D is 2 into 10 to the power of minus 3. So this will go, this will go and it will come 1.5 meter per second. Okay. Now velocity head. Velocity head is, we have h is equal root 2gh. Root 2gh is equal to velocity. So velocity head h equal to v square by 2g. V square by 2g means 1.5 into 1.5 by 2g, 2 into 10, which is equal to 0.11 meter. So nothing but 11 centimeter. So your option C. Yes. Next. So it's a combination concept. Very good. A mercury drop of radius r is equal to 1 centimeter is sprayed into n is equal to 10 to the power of 6 equal sizes. The energy expended in joules is surface tension T is equal to 460 into 10 to the power of minus 3. Then energy or work done. Work done is only the energy. Energy is equal to 4 pi r square T into n to the power of 1 by 3 minus 1. So 4 pi is 22 by 7 into r square 1 into 10 to the power of minus 2 whole square into surface tension 460 into 10 to the power of minus 3 into 10 to the power of 6 whole power 1 by 3 minus 1. So this gives rise to some 5 point something should come, right? So point adjustment, all are with 57 only. So that's a very dangerous thing. You need to adjust in a better way. So this is 0.057, nothing but 5.7 into 10 to the power of minus 2 joule. Option A. Next. What is the rate at which trapped bubble of 2 mm diameter is equal to 2 mm. You need to write it into 10 power minus 3. Diameter rises slightly through a solution of density 13.6 into 10 to the power of 3 kg per meter cube, and quotient of viscosity is 1.5 centipoise 10 power minus 2 poise. Centi means 10 power minus 2, milli means 10 power minus 3. Assuming density of the air is negligible and G value 10 meter per second square. We need to at what is the rate at which the trapped bubble 2 mm diameter rises lightly through a solution of density 13.6 into, that is mercury, and quotient of viscosity 1.5 centipoise. So diameter implies radius r is equal to 1 mm into 10 to the power of minus 3 meter. Yeah, with which velocity it rises? Nothing but terminal velocity. What is that? Terminal velocity. V is equal to 2 by 9 r square g into rho minus sigma by eta. So 2 by 9 r square 10 power minus 6, g value 10 into only one density he is trying to take up, other one is neglecting, 10 power 3 by eta. Eta is 1.5 into 10 to the power of minus 2. Centi means 10 power minus 2 only. So that is equal to 2 by 9. This is 10 power minus 6, 10 power minus 5 and 10 power minus 5. So 10 power, totally 10 powers will go because 10 power minus 2 is there and everything will go. So it will be 13.6 by 1.5 will be there. 1.5 can be written as 2 by 9 into 13.6 by 3 by 2 I can write. So this will be 2 2s are 4, roughly 4 12s are 48 or 4 15s are 60 and 60 by 27. 2 times it will go, right? 2 times it will come. So 20 means one more 0 is there, but here there is no 0 because these two will go and 4 by 3. So I think here they took, instead of centipoise they took millipoise. If you correct it into millipoise, then you will get that desired number. So we shouldn't learn wrong things, we should learn correct things only. If it is so, then this will become 10 to the power of minus 3 and obviously one more 10 will be there, 10 power minus 1 will be there, that is equal to then 20 millimeter per second will come. So if it is millipoise, that will be true. If it is centipoise, only 2 will come. Okay, next. 9 kg solution is poured into a glass U tube. 9 kg solution. Okay. The tube's inner diameter is 2 into the tube's inner diameter, D, is equal to diameter 2 root pi by 5 meter. The solution oscillates freely up and down about its position equilibrium. The period of oscillation in seconds. Time period of oscillation T is equal to 2 pi root h by g is the formula. 2 pi root h by g. Here h is height of the liquid. We have to take like this. Whenever two liquids are of equal height, then we have to take. Liquid suppose this much, then this height we have to take. That is not available. Then you can think like this. Total length of the column by 2 you can take. H is equal to total length by 2 you can take. So h can be replaced with L by 2. How to have total length of the liquid? That we can have like this. He gave mass. Mass m is equal to 9 kg. So mass is equal to volume into density. Mass 9 kg, volume pi r square L into density rho. 9 is equal to pi into r is equal to root over pi 5 whole square pi r square. It's density, diameter, right? Diameter half is radius 1 and L into density. 1 meter cube solution has a mass of 900 kg. That means 900 kg per meter cube. That means density only 900. So this will become 1 by 100. 1 by 100 and this is pi square is equal to pi square by 5 into L. So L is equal to 5 by 100 pi square. Pi square is one more 10. Pi square can be taken 10. So 5 by 1000, that is nothing but 5 into 10 to the power of minus 3 is L. So you can replace and you can calculate using this formula. What is that? T is equal to 2 pi root L by 2G. So that is 2 pi root over L value 5 into 10 power minus 3 into 2G value 20. So this is 2.5 into 10 power minus 4. So 2.5 into 10 power minus, I will use this space. T is equal to 2 pi root over 2.5 into 10 to the power of minus 4. Yeah. So that's after simplification. Easy simplification, T is equal to 2 root over this pi square will come inside and into 2.5 will be there. 2.5 into 10 to the power of minus 4 will be there. So pi square will be 10. Obviously it is 25. 25 under root will be 5. So 2 into 5 into 10 to the power of minus 2. This is 10 to the power of minus 1. That is 0.1 seconds. So mathematical simplification will come with a great number of problems practice. Next, the surface tension and vapor pressure of a liquid at 25 degrees Celsius, surface tension 8 into 10 to the power of minus 2 Newton per meter square, and vapor pressure P naught is equal to 2.5 into 10 to the power of 3 pascals. The radius of the smallest spherical water droplet which can form without evaporating at radius r is equal to how much? Excellent bit it is. So we can use this formula, that is pressure P is equal to 2T by R or 2S by R. Okay, 2T by R is better. 2T by R. 2T by R. That means he is asking R is equal to 2T by P. 2 into T value 8 into 10 to the power of minus 2 by 2.5 into 10 to the power of 3. That means 2 into 8 into 10 to the power of, this is minus 4 then, by 25 will be. I would like to multiply with 4 in the numerator and denominator, 4 and 4. Then what happens? This is 100. 100 means again 10 to the power of minus 6. This is 4 2s are 8, 8s are 64. 64 into 10 power minus 6, 64 micrometers. So next, a cylindrical metal box whose flat surface has an area A is equal to 0.01 meter square rests on a liquid 0.3 mm thickness T is equal to 0.3 mm 10 to the power of minus 3. Upon applying horizontal force of magnitude F is equal to 1 by 3 Newton, the box slides with a constant speed V is equal to 0.09 meter per second. The quotient of viscosity of the liquid is nearby, eta equal to how much? Viscous dragging force formula. So F is equal to eta A dV by dx. So F is equal to 1 by 3, eta you have to, A is equal to 0.01, B is equal to 0.09 by thickness is 0.3 into 10 to the power of minus 3. So you need to do it carefully, and I don't want to waste my time. It is 1.1 into 10 to the power of minus 1 Pascal second. Implies eta is equal to. Okay, next. You can do it, no? It's not a big task. I give you the formula. Energy needed in breaking a liquid drop of radius r into n smaller drops of each radius r is how much? Work done or energy needed is equal to 4 pi r square into T into n to the power of 1 by 3 minus 1. This is basic logical thing. Or you want to have in a different way, that you can take like this: 4 surface tension into change in area. Surface tension into change in area. Surface tension T, change in area is 4 pi r square into n minus 4 pi r square. So, which can be as follows. Option A, correct? Yes. Next. A U-tube having radius of one limb is 2 mm, radius or different limbs, different radius, 2 mm limb, and the other limb is 4 mm, R2 is equal to 4 mm, one is wider, one is narrow. A liquid of surface tension T is equal to 0.03, density is equal to 1500, angle of contact theta is equal to 0 is taken in the tube. The difference in the heights of the levels of the liquid in the two limbs. Height difference is how much? Height difference we need to find out. This can be done using height h is equal to 2t cos theta by r dz. So, height difference is equal to 2t cos theta can be taken common, by dz can be taken common, then 1 by r1 minus 1 by r2 will be. So, narrow one will have more height, broader one will have less height. So, 2t 0.03 SI units only, that's why I didn't mention. Yes, whenever SI unit things are there, I don't want to mention SI units. And into cos 0 value 1 by dz, d, what is that? Water? Any other liquid? U-shaped tube contains radius, contact 0, and surface density is different, 1500, yeah, into dg, 10 into 1 by r1, 1 by small one 2 mm minus 1 by 4 mm into 10 to the power of minus 3. Yeah, it's on further simplification will give you 2, 4, 2, 1 mm. Yeah, next. When a temperature increases, viscosity of gases, temperature increases, viscosity of gases increases, viscosity of fluids decreases, viscosity of liquid decreases, correct only. And water does not wet an oily glass because cohesive force of oil is less than that of the water. Cohesive force of oil is less than that of water. A liquid will wet a surface of surface of the solid if the angle of contact less than 90 only will wet, otherwise it will not. So A, B, C, okay, A and C, B and C false, A is true, C is looking correct. Yes. Theoretical question. Bernoulli's theorem is based on the conservation of energy. And water does not wet an oily glass because cohesive force of oil glass is greater than adhesive force of the oil and glass. Theory questions you can enjoy. Cohesive force of water is greater than adhesive force, and water oil molecules is okay, light. Next, an ideal liquid flows through a horizontal tube of variable diameter. Pressure is lowest where this should be explained. Explainable things I'll explain definitely. Suppose variable cross section. Here small cross section area, more velocity. Here more cross section area, less velocity, right? Now wherever high velocity there is a small pressure. Whenever low velocity there is a high pressure. So automatically these things will come to act. The pressure is lowest where velocity is highest. So option A, yeah. Next, the radius of the bore of a capillary tube is r and the angle of contact is theta. When the tube is dipped in the liquid, the radius of curvature of the meniscus of the liquid rising in the tube is. So this is also, T is equal to h r dg by 2 cos theta. So what could be the probable answer? Yes. So it's there in this, right? Next, If a vessel containing liquid of density rho up to a height h accelerated vertically downwards with an acceleration a naught, then the pressure of the fluid at the bottom of the vessel is given by the equation. It is accelerated downwards. As per that, you need to take up. It's accelerated downwards. So, effective acceleration due to gravity will be G is equal to G minus, because it's accelerated downwards, so A naught, isn't it? This is effective acceleration. So we have pressure P is equal to P naught plus H rho G. G effective I can write. So it will be P is equal to P naught plus H rho G minus A naught. So what is the probable one? Option C, yeah? Yeah. Next, a liquid drop of density rho is floating half immersed. Half immersed. Liquid drop half immersed. Liquid drop. I'm reverse. Liquid should be in blue color and that should be in that color, right? I reverse. Half immersed and surface tension is S and the density is rho by 2. Come again, come again, come again. Read it, read it, read it. Liquid drop of density rho. This is rho by 2. Half immersed. If the surface tension S of the liquid is numerically equal to 10 times of the acceleration due to gravity, if the surface tension S of the liquid is numerically equal to, surface tension S is numerically equal to 10 times acceleration due to gravity, then the diameter of the drop is equal to diameter of the drop. So D is equal to question mark. Any other things I left? Nothing. So we are supposed to find out diameter. We have weight is equal to surface tension force plus buoyant force. Because of that only it should float. So it's a floating condition I can call. Surface tension force is equal to surface tension into length, right? So surface tension is equal to S, length is equal to pi d, 2 pi r, right? Pi d. So S is equal to, he gave 10g into pi d. We have to find out the diameter. This is Fs. And now buoyant force is equal to volume of the body immersed into density of the fluid into gravity. Volume of the body immersed is half of 4/3 pi r cube, 4/3 pi r cube, 4/3 pi r cube into density of liquid is rho by 2 into gravity is G. Okay. Yeah, next. This is buoyant force. Volume of the body immersed and so on. So now next, weight is equal to volume of the body 4/3 pi d by 2 cube into density of the body, whatever the droplet, into gravity G. So on writing the balancing equation, we will get like this. Weight 4/3 pi d cube by 8 rho G is equal to 10g into pi d plus this is 4 pi d cube rho G by, it's further simplification. Okay, 4 pi d cube rho G by 2 into 3 into 8 into 2. 2 into 3 into 8 into 2. So here I have to find out d value. Obviously d square is there. So d, because one d will get cancelled. So it is 4 pi d square rho G by 3 8s are 24. Okay, of course, 4 can be cancelled. Minus 4 pi d square rho G by 2 3s are okay, 6 2s are 12 8s are 96 is equal to 10g pi d I cancelled, and g pi also gets cancelled, right? G pi also gets cancelled. Okay, you can do it. D is equal to some root of, what will come, 80 or 20? 80 by rho. That's it. Next. A body is suspended by a light string. The tension in the string when the body is in air, when the body is totally immersed in water, when the body is totally immersed in a liquid, or tension in air is equal to 40.2. Tension in a water is 28.4. Tension in a liquid is 16.6. Nothing but we can call it as weight in air, weight in water, weight in liquid. Then the density of the liquid is equal to, density of the liquid is equal to, what is the formula for density of liquid on the basis of Archimedes principle? Yeah, if you do it, weight in air minus weight in liquid by weight in air minus weight in water, you will get relative density of the liquid, right? In CGS system, it will come automatically. If you multiply with 1000, you can get in SI system. Relative density in CGS will be automatically nothing but, relative density is nothing but density in CGS system. So you can multiply with 1000, so that you will get weight in air 40.2 minus liquid 16.6 by 40.2 minus 28.4 into 1000. If you do, then you will get density in so-called SI system. So that is equal to, how much will come? 40 minus, so we need to do, no, you can 20 kg per meter cube. I don't want to waste the time, dears. The simplification things you can do, right? A sphere of material of relative density, relative density 8, that means density in CGS unit. Concentric spherical cavity and just sinks in water, concentric spherical cavity. If the radius of the sphere are 2 centimeter, radius of the sphere 2 centimeter, and the volume of the cavity is how much? It just about to what you call sink, right? In such a way it is exposed. Okay, yeah, it is about to sink, right? So upthrust buoyant force is equal to weight of the body. Upthrust is volume of the body immersed into density of the liquid into gravity. Weight, volume of the body, whatever the mean volume, that means cavity you have to remove, into volume into density of that particular body into gravity. So here volume of the body immersed is 4/3 pi r cube minus into density of the liquid. Here it is water, he said, right? Water 10 power 3 you can take, 10 power 3 into gravity gets cancelled, so y is equal to volume of the body is 4/3 pi r cube minus r cube. Actually this is volume of the cavity. So volume of the body, volume of the cavity, and into density of the body. Density of the body is given, that is 8 into 1000. If you do in SI system, you will get the density. So density of the body in SI system is 8000. Yeah. So from this expression, r value is also given 2 centimeters. So on substituting, small r value will come, and then you can get 4/3 pi small r cube, or volume of the cavity is equal to roughly 88/3 centimeter cube. So this is option D. Okay. Next, a closed flux is coming out. So let us read the question slowly. A closed water tank has cross section area A. It has small hole at a depth h from the free surface of water. The radius of the hole is r, so that r is very lesser than root a by pi. P0 is the pressure inside the tank above the water level, and Pa is the atmospheric pressure, the rate of flow of water coming out, volume rate AV, we have to find out. Here in this, the tank is not open. If it is open tank only will have a flux velocity V equal to root 2gh. If it is a closed tank, then flux velocity V is equal to root over 2gh plus pressure difference by rho into 2. So 2p by rho we have to consider. So this flux velocity will become 2gh plus 2 into PA. PA is atmospheric pressure. So P minus PA, P naught minus PA, this is P naught I think, yeah, by rho. So this is flux velocity. Then volume rate is equal to AV, cross section area into velocity. So pi r square into square root of 2gh plus 2 into P naught minus PA by rho. So which is suitable one? Very close options are, that is B and D. Should be very careful. Okay, B is correct answer. Next. Iceberg floating in water with a part of it is submerged. What is the fraction of the volume of the iceberg submerged if the density of the ice is 0.917 grams per centimeter cube? So fraction of ice submerged is V by whole volume. I can write it as V by V is equal to density of ice by density of water. Density of ice is 0.917 gram per cc and this is 1 gram per cc. So answer should be 0.917. That's it. No fraction, no unit. So option C. Next. A cylindrical container containing water has a small hole at a height of 8 cm from the bottom and at a depth of 2 cm from the top of the surface of the liquid. The maximum horizontal distance traveled by the water on the ground is equal to R is equal to 2 into square root of H1, H2 I can call from the top and from the bottom. 2 into square root of H1, 8 cm and 2 cm into 10 power minus 4. That is 2 8s are 16, 16 will come as 4 into 10 power minus 2. So this will be 2 4s are 8 meter and it is centimeter. So option is 8 centimeter. And another question. Hydraulic lift works on the basis of Pascal's law. All are related to fluid mechanics, right? So Pascal's law is correct for hydraulic lift. So these are few questions based on mechanical properties of fluids. Keep on practicing and come with good number of doubts. Bye.